In this genome demonstration, we'll be selecting vertices using the particle velocities. We have a scene that contains a PRT loader loading 100 particles saved from particle flow. They were driven by a vortex force, and we have a plane which has a genome modifier that sets the vertex selection based on data acquired from the particles. We're setting a soft selection, and we can look at the content of the modifier. We're taking the position of the particle and looking up the data from the closest particles around each vertex. We can change the radius in which each vertex is searching for particles, and we're outputting the velocity, dividing by an arbitrary value which scales it up or down, and then we take the magnitude and output as selection. We can enable a push modifier and deform the plane according to the soft selection. Currently we are setting a soft selection that is above 1, and if we check the clamp selection, we are cutting it off at 1. Let's keep it unclamped, and we can enable another genome modifier which takes the selection, divides it by a factor, and then blends two colors using that value, in this case a blue and a red color. So if we play back the animation, we see that fast velocities produce red color. We can change it to 0.5 to be orange. Now we have blue to orange. And we can change the scaling factor in order to shift the balance between the two colors based on the velocity of the particles. Since we are using 0 and 1 for the X value, which is the red channel, we can switch to texture coordinates, disable the vertex colors, and use the U coordinate, which is set by the same component of the calculation, to control a gradient ramp map in a material. We use a tiling of 1, and this gives us the gradient from red through yellow, green, cyan, and blue against going to red. We can once again change the balance of the gradient, and we can open the editor and swap the inputs in order to swap the colors instead of changing the tiling to a negative -1 value in order to flip the direction of the gradient. Another thing that we can do is we can modify our PRT loader. This is the Krakatoa PRT loader. It accepts deformation modifiers, so in this case we apply a noise deformation to the particles, and indirectly we apply a noise to the deformed plane. We can go crazy with the deformations on the particles and produce different displacement and colorization on the plane that is indirectly affected by that. Here it is, playing back in full screen.